Hello again, I'm Satish Singhal. In this video, I'd like to talk to you about static class members. A class member is defined static by appending the keyword static before the member declaration. For example, if we have a patient class, then it could include doctor's phone number for the patient, such as the type is static, data type is long, and this is the class variable name called doctor phone. Okay, as I said earlier, long is the data type, doctor phone is the variable name, and the word static means it's a static member, and its type we'll talk more about soon. There is a special characteristics attached to the static class members. These are as follows. They are independent of instantiation of a class object, which means I do not have to create instance of a class in order to create the static members of that class. You could create them without creating an instance, and you can get access to them through static member functions without creating an instance of the class. What that means is that only one copy of a static member exists for all the objects created for a class. I could create 10 different patient objects, but all of them will share only one copy of doctor phone number, which I showed in the previous slide. So single copy of static members is shared by all the objects of the class. And because the static members are independent of instantiation of containing class objects, they cannot be initialized inside the class constructor, because you understand that constructors instantiate a class object, and static members cannot depend upon instantiation of an object, so they cannot be initialized inside the constructor. Static members are initialized in two different ways, and let us explore that in the next slide. The constant static int data member are initialized in their declaration line by providing a value on the right hand side of the assignment operator. For example, generally for declaring an array inside a class, I might need the array length max, so I could make this declaration static const int max equals to 30. This is available only for int data type. For all other data type, I cannot put a value on the right hand side. Okay, so static const int or exception basically. So in this line, static int const max has been set to a value of 30. Other than static const int, all other static members must be initialized outside the class. For example, if the doctor phone is defined inside the class patient as below, like this, then outside the class it would be initialized as follows. Data type, class name, scope resolution operator, the variable name, doctor phone number, and the initialized value. Okay, so understand this sequence. You have to have the data type, class name, scope resolution operator, name of the variable, assignment operator, and the initialized value of the variable. In case you're wondering whether there is a long data type in C++, it actually is. If your integer is very long, very large in value, something like this, then this data type is used. Okay. If you have constant static members other than int, they follow the same initialization pattern that I discussed in the previous slide. For example, doctor may want to give a message regarding the sodium intake for those patients who might have high blood pressure. So I would, inside the class, I would declare it as follows. Const static string sodium message. And the reason I declared it const, because it will not change with time. It's not int type, so I cannot provide a value here. So outside the class, it would be initialized as follows. The keyword const, data type, class name, scope resolution operator, variable name, assignment operator, and now the initialized value of the variable called sodium message. Please reduce your sodium intake. So as you saw in the previous slide, the only difference is that word const goes in the front because it was declared as const inside the class in the previous declaration. We would like to show you the example of modified patient class in Visual Studio. We have also added the relevant static member functions. There are two important points about static member function. These are that they cannot use the non-static members directly. For example, if I had a patient names in the class, static member functions cannot use the patient name directly. And they cannot use const at the end, const and modifier. Therefore, they are allowed write access to all non-const static members. Okay, we cannot deny them the right access to non-const static members. Okay, so let's go to Visual Studio and look at the class I'm talking about. Here's my patient class, and I've added 1, 2, 3 static members. This one doesn't need any further explanation. All the const static int members can be initialized in the same line. So that's as simple as declaring a global constant. No different than that. These two need an explanation. So as I mentioned earlier, this will be initialized outside the class. So outside the class, my class ends here, and this is my initialization outside the class. I just put a large number here. Obviously this phone number is unrealistic, but just wanted to show you the initialization. So once again, this was my declaration inside the class. This is my initialization outside the class. Long data type, class name, scope resolution operator, static variable name, assignment operator, and its value. Okay. Same thing about the const static member, which is not an integer. Const static string sodium message. I initialize it outside the class. The word const, the data type, the class name, the scope resolution operator, variable name, and on the right hand side of the assignment operator, I put the value. Okay. So let's talk about the const or non-const static member functions. Okay, or more precisely, the static member functions that can give us read and write access to this one, because this is a variable, static variable, and read access only to this one because this is a constant. Okay, so you would recall by now that if something is a variable, we need read and write access to that using get and set. If something is a constant, we only need read access to that. We have no need for the write access. So as a result, I added for the sodium message, which is a constant, a accessor function which is called get sodium message. So let's expand it and look at its body. So all it does, it says return sodium message. Okay, and the word const is there in the member function because it's returning a string. Anytime an object is returned, we put the word const in the front, and the keyword static will also be there because it's operating on a static data member. So word static will be there for the method called get sodium message. Okay, so basically when this function is invoked, it's going to return this string right here. Okay, simple enough. Now the doctor phone is a variable, static variable, so I'm going to need two things for it. One is a setter or a mutator, and the mutator is like this, that it's called set doctor phone, returns a void type. It's a static member function because it operates on a static variable called doctor phone. So whatever value of phn is passed by the user, doctor phone is set to that value, although initial value is this, but it can be modified because this is a variable. And then we need an accessor for this, which is this one, and simply it returns a long data type, static because it acts on a static variable, and just returns the doctor phone. Okay, let us see how these static variable and the constants are accessed inside the main function or modified using the static member functions. So in the first line, I print the doctor's current phone number, and I do that by calling the get doctor phone number static method. Okay, notice how static member functions are invoked. You do not need to instantiate an object of patient type to invoke them. We take the class name, scope resolution operator, and the static member function name, and this invocation is good enough. Now I want to set the doctor phone number to something different than this 999, etc. So in the next line, I called the set doctor phone static member method function. So again, I use the class name, scope resolution operator, function name, and I pass it the value for the new phone number. And then of course I print the new phone number just to make sure that it got set correctly. Okay. Now I have a object here called patient P. I print the patient P string form. I don't believe that is important right now. Let's see. Alright, okay, fine. And I want to print the sodium message, which will print this. And again, I invoke the same way. Class name is scope resolution operator and get sodium message. The last point I want to make is that once you create a class instance, you could invoke a static member function using the class instance also. Like this will give the same message as this one. However, it is our advice that do not do that. Do not use the class object name to invoke the static member function. C++ allows you to do that, but the impression you might get is that this works just like non-static member function, but it actually doesn't. So the correct way to call static member function is class name scope resolution operator function name. Okay. Let's run this program, and then we're going to make some modifications to see what is allowed, what is not allowed. Okay. So we compile it. It was already compiled. We run it, and let's compare this with our main function. So doctor's phone number was set to this value, so the first line prints doctor's current phone number as 9999. Notice no object has been created of patient type, so this is to prove that we have access to static members without creating an instance. Okay. Then I set the doctor's phone number to this new value 111-222-3333, and then the doctor's new phone number is printed by this line here. This comes from the patient P, so let's ignore that output. But let's see this one here. I say patient scope resolution get sodium message. It prints this message, please reduce your sodium intake. And if I use the class object P dot get sodium message, I get the same output as I got without using the class object. Okay. So once again, this is to show that you could use an object of a class to call a static member function, but it is not necessary to do that. We will advise you to use this format here. Okay. Now, we mentioned earlier that we cannot put a const and modifier in the static member function. So let's put a const here and see what happens. And let's compile it. So it failed. So it says modifiers are not allowed on static member functions. Okay. Which means they must have write access to the class variables, even if they are only returning a value. Okay. Let's see. I think I wanted to show something here. If I uncomment this line, this will not compile. I'm trying to get access to sodium message member, and the reason I cannot do that this has been defined private in the class. It's defined in the private area. So the important point to note here is that looking at here, it may feel like to you that it's outside the class that you have global access to this, but really it has to follow the access level declared inside the class. Okay, it's not available with direct access. Okay, so let's summarize for the time being the constant or non-constant static class members. A constant integer static class member can be declared and initialized in the same line, just like you declare global constants. Constant not integer, non-integer data members and static variables, they are declared inside the class, but their initialization is done outside the class by giving data type, class name, scope resolution operator, variable constant name, and the value on the right hand side of the assignment operator. For the variables like this one, we will need a mutator and an accessor. For the constant like this one, we only need the accessor. We don't need the mutator because it's a constant. The last thing I want to talk about static members is that sometimes classes are provided static members just because the member functions perform some procedure, and in order to encapsulate them in a class, we just put them inside the class. You could define those functions as standalone functions. I dislike declaring standalone functions, even though C++ allows it. So if I have a standalone function or group of functions that do something, I would rather place them inside a class and encapsulate them that way. I've done that for this class called file management class. Let me just show it to you. Add existing, hopefully I can find it. File management class. Here it is. This is the class file management. It has all the members public only. There are no private members, and it has those three member functions that you have gotten pretty used to by now. Get valid output file name, defined as static. Get valid input file, defined as static. And give output file instructions, also defined as static. I could declare them as standalone functions, but as I told you, my personal preference is not to declare any standalone functions if I can help it, although at times I may have to. But since these three functions do something related to file management, I put them as static member functions inside the class file management. Now let me show you how I can access these. I'll have to include, let's see, this in here as an include. I think I've done that already. No, actually I haven't. So and then I just want to call this one member function, give output file instruction from inside the main program. So so that I don't have to focus on anything else. I'm just going to put it up front here. Scope resolution, and I got it. So this was a static member function in this class. So class name is scope resolution operator, and I can call it directly like that. Let's compile and run it, and you will see that this whole string will be outputted to the console. And there it is. I call the give output file, and I got that string that declares output file instructions right there. Okay. So basically, we could have static member functions which work with the static and constant static class data members, or we can have static member functions that could have otherwise been declared as standalone function, but for the better management of the code, we put them inside a class. Okay, so hopefully this long video has clarified some of the issues that you might have been wondering about static members. Thank you so much. Bye.